Hi, this lesson will be about gravitational potential energy and kinetic energy. So to begin with, gravitational potential energy is the energy stored within an object due to its position within the gravitational field. Now we can calculate gravitational potential energy by multiplying mass with gravitational field strength with the height. As an equation triangle or a formula triangle, the gravitational field potential energy, goes at the top of the triangle, which is denoted with a capital E followed by a lowercase p, and is measured in joules. Mass is denoted with a lowercase m, measured in kilograms, and gravitational field strength is denoted with a lowercase g, measured in newtons per kilogram, and height is denoted with a lowercase h and is measured in meters. So, for example, if I had a football which had a mass of 500 grams and I threw it up into the air by about 5 meters, what would its gravitational potential energy be, which is stored within the football? So the first thing we need to do is write out the formula which we will be using. So the gravitational potential energy equals mass times gravity, or gravitational field strength, times height. We then need to check the units of the numbers and substitute the letters with the numbers. So the football has a mass of 500 grams, but it needs to be in kilograms. In order to do that, we need to divide 500 by 1000, which gives us 0.5 kilograms. So if we continue with the equation, so we now have 0.5 times, and the gravity on Earth is around 9.8 newtons per kilogram, times by the height of 5 meters, and your answer is 24.5 joules. Okay, so for the second part, kinetic energy. Kinetic energy is the energy stored within a moving object. Whether it is moving very slowly or very fast, it will still have kinetic energy. Kinetic energy depends on two quantities. First one is velocity, and the second one is mass. We can calculate kinetic energy using the equation half times mass times velocity squared. So within a formula triangle, kinetic energy goes at the top and kinetic energy is measured in joules. Half goes at the bottom left. Mass is measured in kilograms and velocity is measured in meters per second. Okay, so if we have a cannon which has fired a cannonball which has a mass of, let's say, 10 kilograms, and this cannonball has been fired at a velocity of, let's say, 20 meters per second, what would the kinetic energy be for this moving cannonball? So the first thing we need to do is write out our equation that we will be using. So kinetic energy equals half times mass times velocity squared. We then need to substitute the letters with the numbers and again check the units of the numbers before we start calculating. So half times mass should be in kilograms, times 10 times velocity, again meters per second, times 20 meters per second. If we calculate that, the answer should be 2000 joules. Sometimes the examiners will get you to rearrange equation to work out velocity, for example. So the first thing we'll do is, again, make our formula triangle, kinetic energy at the top, half times mass times velocity squared, and they will ask you to rearrange and calculate the velocity of an object, where they will give you the kinetic energy and the mass. In order to do that, we just simply cover up velocity squared and rewrite out the equation. So to work out the velocity, it would be kinetic energy divided by half times the mass. But if you look carefully at the equation triangle, or the formula triangle, the velocity here is squared, but we want velocity by itself and not squared. So whatever answer you get here, you need to make sure you always square root it at the end. So the final answer should be v by itself, and v denotes velocity and not velocity squared. So as a worked example, if a bullet was fired out of a gun and it had a kinetic energy of 15,000 joules and a mass of 0.1 kilograms, or let's say 100 grams, what would the velocity of this bullet be? So firstly, we need to draw our equation triangle and put all the quantities in the right place. So kinetic energy at the top, half at the bottom left, mass velocity squared. We then need to write this out as a formula to cover up velocity. So we've got velocity equals kinetic energy divided by half times the mass. And because we don't want velocity squared, we want velocity by itself, we need to make sure we square root our answer at the end. Now all we need to do is substitute the letters with the numerical values, and what we have is square root 15,000 divided by half times 0.1. So the bullet that's fired out of a gun would have a velocity of around 54.78 meters per second.